Alright, so apply electricity. We've been doing a lot of electronics courses from DHS, SS, and then maybe on our own on our own we might even be doing something about electricity, right, or electronics. One of the basic equations that we've been seeing and common that we've been seeing like is this Ohm's law, right? Where V is equal to I, where we are like the voltage across the ends of a particular element, right, is directly proportional to the current flowing through it, provided the temperature or the resistance of the element is constant, right? Then again, in applied electricity, this equation plays a lot of role, right? In fact, is the whole basis for the beginning and even up to the end of the whole course. Okay, our advisor, you really have this equation in mind, and because we've been doing a lot of relation with respect to this one. Okay, definition: a circuit, right? A circuit is an interconnection of elements forming a closed path along which current can flow, right? So we are saying that for this equation to hold, discussions to be made on this equation, we have to have a closed loop, right? So current must be able to move from one place to the other, right? So we have in the element, this is a voltage source. Whenever you see something like this, voltage source, right, V, this resistor, this is what's the name, this capacitor, this is inductor, right? It could be any other element, but this is just an example, just showing that there's a closed loop, right? So if I start from here, I can move from here, this here, and come back. Okay, this is D, right? So it will be something like this: A to B to C to D and back to A. And because I follow something like this, I say it's a loop, right? That's what I'm trying to say. And then the actual elements are the ones that produce energy, or like the source of voltage. So the current sources in the circuit, right? So batteries, generators, solar cells, right? So the passive element, they use the energy in the circuit. So you see resistors, inductors, capacitors, could be bulbs, right? Anything that use the current. The foundation is very, very important. That's why I made a relation to this one, right? So get these ones and then get these ones. So get the whole concept of active element, passive element, and then this equation, and then you'll be fine. Okay, and then we are saying that whenever we have a circuit, this one is a circuit, right? I'm coming. This is a circuit. So when you look at this particular circuit, you see there are some places where the wires bend or something, right? It's not that it should actually bend, okay? But this is what's happening. If I have a wire like this, right? Let me use blue. I'm just trying to draw a distinction between the node and the junction. If I have a wire like this, and then I end up bending the wire to something like this, right? You will notice that it's actually the same wire. It's not actually a place where I've joined. It's just a full wire that I've bent, making it this way, right? After I bent it, right? This bent wire, okay? Not like I bent, you get me? So it's the same thing. What they are trying to see in this particular case is that whenever you're having a circuit, so when you look at this particular one, we could say that this from here to here, just one wire that has been bent, right? Here to here, just one that has been bent. But then when we have a point like this, right? When you look at this point here, 1, 2, so that's C, D, E, and then F. When you look at this point, you see that there are more than wires at that junction, right? How many wires are there? You can see that here's 1, this 2, this 3, right? Here 1, 2, 3, right? And then 2, 1, and then 3, right? The same here. Okay, write them all. I think we'll be fine. So have 1, 2, and then 3. Here we have 1, 2, and then 3. Here we have 1, 1, 2, and then 3. 1, 2, and then 3. Right? Because we are talking about these points. At a particular point within the circuit, right, where we are having more than one wires joining, right? There are two words that we use. We have junction, right? And then we have a node, right? We see that particular point is a junction when the wires there are 2, right? And then when we describe a particular junction to be a node when the wires connecting at that point are 3, right? So looking at these ones closely, then again, these are the basic concepts, but when you understand them, it will really, really help you later on. Are we okay? So when you look at this particular place, that's C, D, E, and F, you see that the wires here are 3. So meaning that C, D, and F are nodes, right? These are nodes, right? Yeah, we are still on the basic concept, the terminology. A branch is any path along with a branch, a path, a connection or a path between two nodes, right? So if I'm having this is a node, right? Pair what we did here, this is another node. So this all here is a branch, right? All here is a branch. Sorry, there's no branch. So all this become one branch, right? Because the nodes are two here. That's E and F. So the whole of this is one branch from here, here, and then here, right? There's one branch. About, yeah. And then we say a loop. A loop is a closed path, right, within a particular circuit. So you see, if it were to be something just like this, let's say that's what we've been seeing so far a lot. Like if you have something like, let's say a resistor, let's say a voltage source. If I happen to have, let's say, a bulb or something, right? A bulb, something like this, right? This is a circuit, right? But I could also say it's a loop, right? Or a mesh. But when you look at this one, it's actually a full circuit. But it's also possible that within this particular circuit, we can get other circuit. So when we have any other circuit within a particular circuit again, we say that one is a loop or a mesh because a loop closed, right? We can move along it. So I can have this one here, right? Or let me see another color. I can have something like this one here, right? Or I have this one too, right? Or I could have something like what's the name? Another color. Okay, I could have here and then here, right? Or I could have this. So whichever one that you choose, so far as it's actually you can move from that part from one point and get back to that point again without having a space, right? Meaning that it's a loop, okay. But then again, this here is not a space, right? The space within these two bars here are not a space. It's actually a battery. That's the symbol for it. So far as you can move along a path and then come back from a point and then come back to that point, and then you are not having to pass through any space or something, we are saying it's a loop, okay. And at times we use the letters to describe the loop, okay. So you see, even for the branch we use CD here, this, and then this. We just use these letters for identification. They are not that much important when you are doing analysis, but the circuit analysis, but it's very important for identification. It makes your work easier, okay. So then we can use so you see CJHDC, right? Where is it? So we start from C, right? So meaning when you're talking about a loop, meaning that you start from that point and you end at that point. That's what makes it a loop. So where is C? C, where's J? G, right? And then we have what? H, and then we have D, and then C, right? So there's a loop, right? Another terminology. So we see a short circuit is when you actually introduce just a wire, right? Just a wire of without any resistance there. You just place a wire there, meaning you short circuited something. Okay, so it's saying that a branch of theoretically zero resistance, meaning the resistance across it is assumed to be zero in theory, right? It diverts all the current that passes through it. It diverts all the current to itself. What current that would have flown through an adjacent branch, that would have flown in adjacent branch, right? Adjacent branches. Branches hooked to the same node, the same branches with sources. What I'm saying is that let's say we have a circuit like this. What is it? This right now. Let me label them so we know where we are. Okay, so this one and then this two, right? Two, right? What it's saying here is that if I'm trying to draw the one, this is one, right? This is a circuit. This is a voltage source. Then again, the symbol is very important when we are doing these ones. They make our identification easy. Okay, this another one, and there's another resistor. As usual, the resistors use R and stuff just to represent them. Okay, I've just removed that side, that wire there, so I could see what's happening. Where is it? This thing. Let me draw the sidewall. The labeling: C, D, E, F, and then H. So generally, there's a voltage source in the diagram in the circuit, right? There's a voltage source. So if current were to be flowing, it will move from here because there's a positive terminal and negative terminal, right? So it will move in this direction and then come here, right? Pass through this, and when I get here, the same current will split. So if here is current, one current, this is, let's say, I1, this is another current. Let's say this is I2, right? This could be another current I3. So if it's split, this just by the way, but I'll mean it later. Meaning that this I1 here will be equal to I2 plus I3, right? Yeah, there's a nice term for it that they've used, so we'll meet it later. So that's what would have happened, right? And then this 1 and 2, this is still this I3. This I3 will still be here, right? I3, right? And here is still I2, right? They'll meet again and then we'll have our I1 back and then to come back to a negative terminal of the voltage source, right? That's what would have happened. But here's the case where we've introduced a short circuit. What it's saying is that because we have a short circuit, right? They are saying theoretical resistance. Theoretically, the resistance is zero, meaning that it's having zero resistance. One thing about current is that it will always pass the place where there is least resistance. So imagine like there's a path, right? Let's say a double road, right? And then you are driving, you're on this side, there's your car, right? And then you've seen up ahead that when you're at this point, you've seen up ahead that they are both in this way. The roads are both this way, going in one direction. You've seen up ahead that there's traffic here, right? Or because something happened and there's a traffic. But you are here, you're about to get to this point. Because you've seen this, you definitely want to change your path and then use this side. Because here, what's happening here? There's least resistance, right? There's no traffic here. This road is open, right? You want to move from this side or the lane that you are and then come here and then join this and be in this lane because there's no one here, right? There's no resistance. So that's the same thing for current. What the current to do is that because now it's the same diagram. I'm coming. It's the same thing. The current behaves the same way as how humans do in this particular case. Alright, I'll continue. So we're talking about the resistance, right? So definitely when you see a traffic jam ahead, you want to avoid that traffic jam ahead and then move in this direction, right? To be here. So current behaves in the same way to take the path of least resistance. So that's what this whole thing means. This is a short circuit, right? So now that we've introduced this, I'm trying to introduce the short circuit there. Are we okay? Let me move this down. So the same circuit here, it's just the same one, but now I'm trying to introduce the short circuit, right? So there's then again, current always take the path of least resistance, right? So there's it, the same circuit. Resistor 1, resistor 2. I'm coming. Okay. So resistor 1, resistor 2. It comes here, right? Let me bring this side. Voltage source. Okay. At times you see battery, but here's the case where it's not always that we have a battery. So in applied electricity, we most of the times we say voltage. We say it a lot. Voltage source. Are we okay? So if you say it, don't be alarmed. It's just the same thing. Using different terms because of the scenario that we are in to describe it in another way. Are we okay? So now I'm introducing the short circuit. Let me use red to show it. So if I have the short circuit here, right? Just by the way, what are these points, right? The points that I've made here, this one, B and then G, right? They are definitely not junctions, they are nodes, right? Because there are 3 wires here, right? So we have one wire, another wire here, one wire, another wire here. So these are nodes. Are we okay? Not junctions, just by the way. So then again, we are trying to see how the current will flow, right? Then again, this is a short circuit, and we are saying that a short circuit is a branch of theoretically zero resistance, right? And then, so you look at this one here, the current move from here, the current moves from here, it gets here, there's one current split here. But here's the case, the same current here, there's the I1, right? When it gets here, then again, it's like the road scenario, right? Where is it? Let me bring it close so we see what's happening. Okay. Yeah, we are good to go. So the same thing here. So now it's at this point. So right, this is where we are. So let's say this is A, position A, right? This position A, right? The same thing here. So now it's here. this is the position that we are now. We've seen the traffic jam ahead. So the whole of this side here is our traffic jam, all here, right? Traffic jam because they will slow you down. These are resistance, right? So meaning that they will have some resistance, like they will have some restrictions, right? Some opposition, right? That's the term. So now you've seen it. Like you are the driver, right? The current is the driver. There's a current. This I1 here is the current. So now you've seen the traffic jam ahead, which is all this side, right? Definitely you want to avoid all that and take this free part here. So this empty, the part where is not jammed out, let's say this is RZ, right? This same here, this short circuit here will be RZ. So you definitely want to avoid all the traffic. That's how the current will behave, right? And then pass through this side, right? And then all of it will pass here. So that's that same thing. That's why we'll have an I1 here. The same thing will come here. So it flows from this part here, and comes back. This is the same I1 and come back to voltage source. Negative side, positive side. Then again, be very familiar with this. A voltage source, right? The long bar is the positive side and the short bar is the negative side, okay? It will help a lot later, but I'll get the conversion. So you see, this short circuit here, there is no, what's the name? There is no element within it, right? So we are saying that it's a part of theoretically zero resistance. So it's like your open space, open track when you're on the road, right? So the current you definitely want to use that part and come back here. Yeah. Then again, we are still doing the basics. We are not anywhere here. So what's the name? There's what's the name? There's kind of like a short. Is it an example? Self-assessment. Okay. Which of the resistors below have been short-circuited? So let's see. What's the short circuit to make it clear? What's the short circuit? So there's a voltage source, right? So if the current is flowing to pass here, and then when it gets here, if this is I1, right? There's I1 again, right? When it gets here, it has seen these two guys, right? There's no other way for it to pass, right, than to pass through here. So to definitely have to split to here. If here is I2, here will be I3, right? Right. So you have to pass through these guys. Pass through these guys and then come and pass here. Are you okay? That's the general way. But then they are saying, say, there's some short circuit. So what do you think is a short circuit here? A short circuit is a part of theoretically zero resistance, right? So looking at this here, you see that it's actually related to a traffic jam scenario. So like you're on this part, right? There's the road. Now let me use lines to show the road. So there's your car. There's a road here. You are trying to get. It's actually. I'm coming. There's your car here. Right. There's one part here, and there are cars here. There's another part here, and there are cars here. Right. And there's another part here. Right. And all these parts come and join at this point and then come back here. But you're trying to move from A to B. But then again, the road is a one way. You can't move in the other direction, right? So you definitely have to pass here. But now that you are here, seeing these two parts ahead, now that looking at where you are right now, which is here, there are three parts, 1, 2, and then 3. So looking up ahead, you see that this part is occupied. So this is out, right? This part 2 is occupied, so this is out. Though this side is a longer part, you definitely want to choose here because here it's free. You choose to move here, part of least resistance, right? So and pass here, right? So looking at this diagram again, it's the same scenario. There's your car, other cars here on the lane, right? So you definitely want to choose here, pass here, and then come and pass here. So meaning that these two circuits here have been short-circuited. So which of the resistors in the circuit below have been short-circuited, right? So looking at how the current will want to move like a driver, but you want to avoid these two resistors, right? So your part of least resistance will be here, and then here. So you want to move here, 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 and here. So meaning you've avoided these guys. So they've been short-circuited. You've avoided them, right? That's what I'm saying. And then an open circuit. An open circuit is where like you introduce an open space. So you see where like the short circuit is a part of it's a part of theoretically zero resistance, right? The resistance is 0, right? And then so that's a short-circuited part, right? And then we have a closed circuit. A closed circuit is where we say that the resistance there is infinite. So like the circuit you want to So in as much as a short circuit is where if it's to be a road, the short circuit is this side where there are no cars up ahead, right? This will be your if there were to be, let's say, 2 cars here, let's say 4 cars here, right? The open circuit is where there are like an infinite number of cars, like bull long cars. That's not a word, but like I'm just using it. Like a million cars or a zillion or decillion cars, right? Up ahead, right? A lot of cars, so a part of infinite resistance, right? A lot of cars are like it's actually congested, right? So that's what we see is an open circuit. So we introduce this using, so you see for the short circuit we just use a bar or like a straight line. So like in this case here, just a line, right? To show short circuit. That's it, right? An open circuit is where we just open it, just like in this form, right? Chiso said there are a lot of cars here, right? You have to pass through a lot of cars actually to get it. So if you are coming from this direction, from A to B, it will take you a lot of effort to pass here because that place is open circuit. You can there's actually an electronics explanation behind this, but I'm just using the car congestion traffic to help us understand that. Okay, so open circuit sorry, open circuit meaning that the resistance here is infinite, a very huge resistance. So definitely resistors current to actually want to avoid those parts because they don't want to spend a lot of energy about. So that's what happened. So if there's a voltage source, let me open this up. There's a voltage source, right? So definitely this then again positive negative direction. The current is flowing from this side. It will definitely pass here. When it gets here, it will see that it will sense that there's an open circuit here, right? Infinite resistance. It will definitely avoid that side and then pass here, right? And then come and pass here, right? So if the current here is, let's say, I1, the same current to be here because it is avoided this side, and the same current to be here too. The same I1. Are we okay? Yeah. Then again, we are still on the basic, the terminologies. We are trying to get the concept. Okay. Yeah. All right.